So, what is a software system and how does it differ from just regular software? So, software system is a collection of all the programs. So, it could be many multiple softwares working together, all the components and all the resources that relate to it. So, it doesn't have to be technical, right? Code. Sometimes it might be documents. So, we're going to talk about that in the next slide. So when we're talking about software systems, it's not just the application software, which is the part that you interact with. It's also databases. So databases make it so that application like Facebook or some of the Google workspace products, right, that have millions and billions of users, they make it possible for you to be able to retrieve your information, your data very, very quickly. Even if there's a billion people, right, that they have to, kind of search through to find your information, databases make that magic possible of handling so many records and still managing to do it in, less than a second whenever you're logging in or interacting with your particular data. System software, which is great. We've learned about how that's different than application software. It's great in the sense that if I build a new application software, I don't have to worry about which computer it's going to run on. It could be a Lenovo, a Dell, a Mac, any computer that you can think of, right? Any PC. I don't have to worry about which system it's running on. The OS will translate, right, my application software to work with that specific hardware. There's also mobile operating systems, right? So if I want to build an app for the Google Play Store or for the App Store on iOS, then I can interact with the camera, the GPS, your microphone. Maybe you shake your phone or you do a swipe on the phone. All those things, the operating system makes it easy for me to interface with, to work with, so that if you do any of those inputs, right, I can provide you with the right output from my app. So yeah, they're very well built, those operating systems, Android and iOS. I've had the opportunity to publish to Android, and yeah, it was actually not that bad working with that operating system. I was surprised at how much support there was for young and solo developers such as myself. And then we have interfaces and APIs. It turns out you can actually, rather than building everything from scratch, you can get like pre-bought items, right? Such as, let's say you were cooking, right, a meal. Sure, you can make everything from zero, or you can buy some of those ingredients from the store, right? So you don't have to do everything yourself. Well, the same case is for building software. There's a lot of pre-built systems out there that you can kind of plug into your own system, sometimes for free, sometimes for a small cost. Definitely the cost, right, is something you consider when you're building your apps. Hey, how many APIs am I using? How much is it going to charge me? Then I have to pass that cost over to the user, maybe as a one-time fee or maybe as a subscription fee, right, that they pay every month. So that's software systems. It's not just one app, right? It's not just one component. It's a lot of things working together. And it's not just the technical stuff. It's not just the code. It can be the documentation. So documentation will have details on how to use the app, what kind of requirements you need for the app, right? So if you've ever downloaded a, very very new video game, that video game not might not run on a very low resource laptop. It might need a specialized gaming laptop or desktop system. So same goes with software, right? Maybe you can't run this app on iPhone 1, right? So maybe you might need to have a certain version of an operating system. So that'll all be in the documentation. There's maintenance records, right? For what changes have you made to the app, what updates have you made, and then there's test results. So it turns out testing is a huge component of building software. In fact, that's a role on its own. So I might be the software engineer who builds the app, but as I'm building the app, I'm accidentally introducing bugs. I'm making mistakes in my code. And those bugs can ruin, right, the functionality of that app, of that software. So a quality assurance engineer, excuse me, or a test engineer, their sole job is to make sure, hey, is this app working like it's supposed to? If I give it these inputs, will it give me the outputs that I expect? And you have to be constantly testing because we're constantly improving these applications, right? If you think of any enterprise software, a software that is, sold or available to millions of users, they're constantly updating it. They're constantly improving it because they're finding bugs. Maybe they find security vulnerabilities, Remember in our lesson on internet, it's important to update your software because we're always finding new ways to strengthen that security. So testing is hugely important. And something I want to remind you as a student, because I see a lot of this with students, they hate making mistakes. I can tell you as a software engineer, that's part of the job. And that's part of the job for most engineers is making mistakes. So that doesn't go away because you stop being a student. So remember, even as a student, mistakes are part of the process, part of the learning process. And for the most part, if you're making mistakes, it means that you're challenging yourself. You're doing something difficult. You're learning something new. So I want you to embrace those mistakes, right, as part of the process in the same way that us engineers embrace it. I can tell you, I learned more from debugging, fixing those bugs in my code, than I did from just getting my perfect code on the first try. Every time I had to debug the code, I had to think critically, I had to investigate, and every time I had to do it, I was reminded of the pain, right, that it took to find that bug and to fix it, so that I wouldn't make that same mistake again in the future. So coding, right? So coding, I remember when I first started to learn how to code, I was like, how does this translate into an iPhone app? How does this translate into an Android app or to a website? So if you know how to code, you know how to build a software system, right? Not exactly. Coding is definitely important. It's a core skill. It's fundamental to building software, but it's not the only thing. It's not the only thing when it comes to software, and that's why there's so many different roles in the tech industry. So programming languages are formal sets of instructions that allow us developers to tell the computer what to do, to be able to build custom software. So they provide rules for writing the code. So I have to follow very specific rules, just like in English, right? There are certain rules. In Spanish, there are other rules. Same with programming languages. In Java, there's a certain set of rules. In Python, there's another set of rules. Those are examples of programming languages. So they enable us developers to create apps to run on various devices and platforms. So when I first started to learn how to program, I thought that programming was going to look like this. This is an example of a low level language. So low level languages are close to machine code. Remember, machine code is the binary, the zeros and ones. So these, numbers look very scary. These instructions look very scary. And they are scary. I actually did take a class where I had to code in assembly language. There are still applications for this, such as systems programming and embedded systems. Maybe you're working with industrial machines. Maybe you're working with cars, right? Self-driving systems. uh, this is some applications, right, of low level languages. A lot of legacy systems too. If you're working with really old hardware or machinery, you might be coding in assembly. Um, there are applications for this, but this is not the typical programming that we're talking about when we talk about software development. Again, there is space for this. Um, it's very hard. I did not enjoy taking these classes, right, and having to code in assembly. It definitely made me appreciate the high level languages, which we'll cover in the next slide. But yeah, coding is not this like nonsense, kind of hieroglyphics. It's actually a little bit closer to human language than you think. So high level languages are languages that provide more abstraction from the hardware. So that means they're closer to the human language. So some examples of these languages include Python, Java, C++, JavaScript, SQL, which is specialized language for databases. So you use these languages to build apps, websites, for data analysis, scientific computing. And here we have an example of some Python code. So take a look at that code, see if you can figure out what it does. I'll explain in a second. So essentially, what this code does is we're storing a user's input. We're saying, hey, what is your name? The user will type something in, and we're storing it in a variable. We have variables in math. Well, we also have variables in programming. That's why math can be a very useful skill for programming. Not essential, right? You can be terrible at math and still become a pretty decent coder, but it definitely helps a lot to be good at math. Math is about following rules, critically thinking, solving problems. Same with programming. There's a lot of parallels. And as we can see with variables, that's one. So this variable is going to store whatever name they put, right? It could be William, it could be your name, it could be any name in the world. That's what makes this program dynamic, meaning it can handle different inputs and transform it to different outputs. So it's going to take whatever name you put in and plug it into this message. It's going to print it out and say, hello, whatever name they typed in, nice to meet you. So boom, it seems like this app is smart, intelligent, right? When really it's a very simple program.